Okay, so this first one that we're doing, we're working with rational equations, and we should have graphed these a while ago. Like, I don't know why we didn't. That was kind of my mistake, but let's look at this one. So if we have f of x equals x cubed minus 2x squared minus 8x, and it's over negative 4x squared plus 12x. Okay, this whole assignment, all you're doing is you're simplifying the rational equation, and then you're finding the wholes. Okay, there's also asymptotes, and there's a lot of other stuff we're going to eventually get to. There's only 3 days, but we're going to get to graphing these. So first thing I'm going to do to this is factor it. So on the top there, I can factor out an x. So I'm left with x squared minus 2x minus 8. And on the bottom, I can factor out negative 4x. So that'll be negative 4x and then x minus 3. And then I'm going to factor the top more using the x. You can see what multiplies to be negative 8, adds to be negative 2. Well, it's negative 4 and positive 2. So then that's going to be x minus 4, x plus 2. And that's over negative 4x and x minus 3. Okay. Now at this point, the wholes, this is completely factored, which is always your first step. Just completely factor it. And then you want to see, like, where do we have a common factor on top and bottom? Because wherever you have that common factor, that's where the whole is. So since we have these x's right here, that's where our whole is going to be. So if we canceled those, for the whole, you just take whatever you canceled and set it equal to 0. Like, and in this case, it's super easy because it just equals 0, right? But we still need to find the y value to this. So this is the x part of it. We need to figure out what that y value right there is. Okay, so if we cancel that, we're left with x minus 4, x plus 2 over negative 4 and x minus 3. The way that we can find the y value for this is to take this 0 right here and plug it in wherever we have an x. So I'm going to plug it in at the 0 minus 4, 0 plus 2, negative 4, 0 minus 3. So if we do that, so if we do f of 0, we get 0 minus 4, and then 0 plus 2 over negative 4 and 0 minus 3. Well, 0 minus 4, that's just negative 4. That's positive 2. That's going to be negative 4 times negative 3. Which on top, that's negative 8 over positive 12, which then reduces. 4 goes into both of those. 4 goes into 8 twice. 4 goes into 12 3 times. So our point here is 0, negative 2. And that's all you do. So this is part of your answer minus like the blue in there. And then this is the other piece of your answer there. Okay, any questions with that one?
So I'm a bit confused as to how you found the x value for the whole.
Okay.
So, yeah.
So right here, you see how we canceled these x's? We had that common factor on top and bottom. Yes. Since there's that common factor, you set whatever it is. And in this case, it just happened to be x. Like, we're going to do another one where it's not just x. But since this was just x, I set the x and I set it equal to 0. And then you would just solve for whatever it was. So say that was like x minus 1 equals 0. Then you would have ended up with x equals 1. If that was the thing that you canceled. But in this case, we just canceled the x. So that's why it's just x equals 0.
So the whole x value is just the greatest common factor?
Not always. It happened to be in this one, but it's not always the great. Like the next one we do, it's not going to be the greatest common factor. It's going to be just a different factor. It can be, but it's not always that.
So is it like the first thing that can cancel out between the top and the bottom?
It's whatever cancels. So you could have multiple holes. It's just whatever is canceling in top and bottom.
Okay.
Okay. Any other questions?
Are there going to be ones where there will be multiple holes and we have to find the X and the Y for each hole?
Yes. I'm not sure if I put any like that on the homework, but there is potentially those. So like you could have that.
Okay, cool.
Okay, we okay with that one? Okay, let's do another. So let's do f of x equals x squared plus 5x plus 4 over 4x squared plus 4x. Okay, the first step is always to factor everything. Okay, always factor everything. So in the top there, you would see what multiplies to be 4, adds to be 5. Well, that's 4 and 1. So this is going to be x plus 4, x plus 1. In the bottom, we can take out a GCF. So I can take out a 4x, and that's going to be x plus 1. Okay, so now that is completely factored. So now, once it's completely factored, you look and see where do we have something in common on top and bottom, and you won't always have it. So say that like this was, I'll erase this in a second, but if this was a 2, then there wouldn't be any holes. So that would be your final answer, and you just say no holes. But that didn't happen in this. We do have a hole here. We have that 1. So we can cancel these ones right here, that x plus 1 and x plus 1. And to find the hole, that's what I'm going to set equal to 0. So I'm going to have x plus 1 equals 0. And then you just solve this. So that's an easy equation to solve. It's just x equals -1. So that means the x value is -1. I just need to figure out what the y value is. To do that, since these cancel, we go to our simplified version of this equation. So that's going to be x plus 4 over 4x. X. And then you take whatever value you solved for x, and you're going to plug that into the equation. So I'm going to plug -1 into the x's. So this is going to be f of -1 equals -1 plus 4 over 4 times -1. And a lot of times the y value is some sort of fraction. So -1 plus 4 is 3. 4 times -1 is -4. So this is -3/4. You can just pull that negative clear out to the front. So we have a hole at -1, -3/4. Okay. Questions on that one? Okay, we're okay with that one.
So are there going to be any questions on the homework where there's no holes?
I don't remember. I haven't gone through the homework, to be honest. There is potentially one where there's no holes. Do you want me to do one where there's no holes?
Yeah, I was just doing it, and on 1, 5, and 6, I couldn't like cancel anything, so.
I will, let me do one more example, and then I'll pull up the homework and see what's going on, okay? Let's do number, no, let's just do this one. So, we have f of x. Oops, I want to do that in black. F of x equals x squared minus x minus 6 over negative x squared plus 7x minus 12. Okay, pretty straightforward. A big reason why I want to do this one, if you have this negative right here, and I think this has, like, we've all kind of realized this, but you always want to pull out the negative leading coefficient. You don't ever want to factor something with a negative leading. So since this is a negative leading, we want to pull that out. So then to factor this, before I factor it, let's just rewrite the top. So x squared minus x minus 6. On the bottom, I'm going to pull out a negative, and then I'm left with x squared minus 7x plus 12. Then we can go through and factor this further. So the top, we see what multiplies to be negative 6, adds to be negative 1. So this is x minus 3 and x plus 2. On the bottom, we see what multiplies to be 12, adds to be negative 7. Well, that's x minus 3 and x minus 4. Again, we have a common factor here. There is a good chance that, I'm pretty sure, like, after I made this just on CUDA, and there is a lot that pop up where there's no hole. So if nothing factors, then just, there's no hole, and then you just leave it in its simplified version. But here we do have stuff that cancels. We have this x minus 3. So then for the whole, I'm just going to set x minus 3 equal to 0, which means that x equals positive 3. So our x value there is 3. And sometimes, I don't think I gave you any like this. I think I did some on the video like it, though. These will be like p's or something. Even if that's a p, the first one you solve for is always the x value. So even if like the variable that's given to you isn't an x, whatever you solve for very first is your x value. And then these cancel, so I'm left with x plus 2 on top and then negative x minus 4 on the bottom. So to find the y value, I just plug the 3 in. So this is going to be f of 3 equals 3 plus 2 over negative 3 minus 4. Well, 3 plus 2 is 5. Negative 3 minus 4 is negative 1. So that's going to be 5 over positive 1, which is positive 5. So the point is 3, 5. Okay, questions with that one? Okay, is there any from the assignment that you want me to go through?
Can you go through number 2 on the assignment?
Yes, so let's do (5n squared minus 24n plus 27 over 10n squared minus 48n plus 54. I need to grab a calculator. Okay. So here, this factoring is a little bit harder. The top, we're going to have to use some sort of slip and slide. The bottom, it looks like we can pull out a GCF. I think it's just a 2. So let's do that first. So on the, that's going to be 5n squared minus 24n plus 27 over 2, and then 5n squared minus 24n plus, oh, it's the same exact thing, plus 27. So this is an example where we're going to have 2 holes, I think. Yeah. So since these both completely completely cancel, let's just factor it so we can figure out what those 2 holes are going to be. So here, if we factor that, so if you use slip and slide, I'll do it over here. So 5n squared minus 24n plus 27. Oops, that's not a 7. So we're going to multiply the 5 to the 27. So 5 times 27 is 135. So this is n squared minus 24n plus 135. I'm going to use my calculator here. So we want to see what multiplies to be 135 adds to be negative 120 or negative 24. So if I'm just going to go to y equals and do the 135 divided by x and go to the table. And it looks like negative 15 and negative 9. So this is going to be n minus 15 and minus 9. And then divide by 5. And if you factor this differently, completely fine, doesn't matter. So divide by 5. And so I'm left with n minus 3 and 9n, or 5n. Whoa, sorry. 5n minus 9. So over here, this is going to be n minus 3, 5n minus 9 over 2, same exact thing on the bottom. So n minus 3, 5n minus 9. So this is an example where we're going to have two wholes. Okay. Am I good to erase all of this stuff over here? Hopefully, no one said anything, so I'm just going to erase it. So then we have two wholes here. We have the n minus 3, and we have the 5n minus 9. So for our wholes, we're going to set n minus 3 equal to 0, and 5n minus 9 equal to 0. From this one, I end up with n equals 3. Okay, and that's the first thing we solved for, which means that that is the x value. So we have some x value here of 3 comma something. Okay, if you solve for this one, you add the 9 over, you divide by 5, so you get n equals 9/5. So we have another whole of 9/5 comma something. Okay, we just got to figure out what that something is. Okay, and if we simplify this, these cancel, so I'm just left with 1/2, which means that whatever I plug into this function now, I'm going to get 1/2. So that means that if I plugged 3 into here, there's nothing to plug it into. So that means f of 3 equals 1/2. And same thing of f of 9/5. This is just a horizontal line at 1/2. That's all that this is, with two holes in it. So f of 9/5, there's again nothing to plug in, so that would also be 9/2. Okay, so this would be like your simplified version of that equation. These are your holes right there. Okay, and this was number 2 on the homework.
Could you also do number 8 on the homework?
Yes. And am I good to clear this off? Hopefully. Okay, so here we have 6m cubed plus 14m squared plus 4m over 4m cubed plus 16m squared plus 16m. Okay, first thing we want to do is factor this. So in the top, I can take out a factor of 2m. In the bottom, it looks like I can take out a factor of 4m. So if I take out that 2m on top, I'm left with 3m squared plus 7m plus 2. If I take out the 4m on bottom, I'm left with m squared plus 4m plus 4. Okay, and then let's just keep factoring. Before I cancel anything, I'm going to just factor it completely, because you might have multiple holes here. There might be something where that happens. So let's factor the top. So first we're going to multiply this over. So that's going to be m squared plus 7m plus 6, which that then factors to m plus 6 and m plus 1. Since we multiplied by the 3 to begin with, I have to divide by it. So I'm going to divide by 3 on both of these. So I end up with m plus 2 and 3m plus 1. Okay, so the top of this ends up being 2m, m plus 2, and 3m plus 1. The bottom, we still have that 4m. This is easier to factor. What multiplies to before, as to before, well, it's 2 and 2. So this is going to be m plus 2 and m plus 2, which this is going to do something weird to our equation here. I'm glad you asked this. So now it looks like we have 2 wholes, but we really only have 1, and I'll show you why. But we have this whole right here of those m's. And then we also have this m plus 2. Okay. Now I'm going to erase this real quick. So let's just write those 2 wholes out. So we have a whole that m equals 0 and m plus 2 equals 0. So for this one, it's just m equals 0. So that means this is going to be 0 comma something. And we'll figure out what that something is. Then on this whole, I end up with, subtract that over, you end up with -2. So this will be -2 comma something. So this is m equals -2. Now, let's go back and simplify this. So these cancel. These simplify. That will become a 1. That's a 2. So I'm left with 3m plus 1 over 2 times m plus 2. So first, let's plug the 0 in. So if I plug 0 in, so f of 0, I end up with 3 times 0 plus 1 over 2 times 0 plus 2. Which that 0 plus 1 is 1. 2, this ends up just being 2, so that's 4. So you get 1/4 there. So we have a whole at 0, 1/4. Now for this one, let's just try plugging it in, see if it works. So if we plug in -2, we end up with 3 times -2 plus 1 over 2 times -2 plus 2. Which that's -6 plus 1 is -5. On the bottom, we have 2 times 0, which means that we end up dividing by 0. And since that happened, and we're going to get into this next time, since this happened, this is undefined. You can't divide by 0, which makes this not a whole. It's actually an asymptote at -2. So, and we're going to get into asymptotes next time. We've kind of briefly talked about asymptotes before, but that means that here at -2, there's an asymptote that is going to trump the whole because the asymptote goes along the whole thing, whereas the whole would have just been a point. And since that we had like a factor cancel and the asymptote just takes precedence over the whole. So in this one, we only have one whole at -1/4, and then this would be your simplified equation. Or at 0, 1/4, not -1/4, but okay. Questions with that one?
What number was that again?
Number 8. Yeah, this is number 8. And it looks like there's only 10, so I've done 2 of them for you. Like if you look at number 3, I'm not going to do it, but make sure you put the numerator there in standard form. It's 63 plus 11n minus 2n squared. Put it in standard form first and then factor it. A lot of these have GCFs, so just make sure you're pulling out those GCFs. Okay. Other questions with this? Okay, so for the homework, it's kind of just like the last two homeworks we did in the last unit. It's just a paper assignment. You can either print out the paper or just write it on a separate sheet of paper and then upload that. And I'll upload one with my work tomorrow so that you can double check and make sure you did them all right. Okay. Okay. Cool. I'm going to stop recording this. I'll post it for the people who didn't get it, or like if you need to go back and watch it.